Okay, good morning and welcome back to electric circuits. Let's continue our discussion on AC analysis, also called as what? Sinusoidal steady state analysis. A couple of important points we'll recall from yesterday's discussion. The most important point is what? If the circuit is what? Linear. If the circuit is what? Linear. And if the circuit is driven by a sinusoidal source, if the circuit is what? Linear, and if it is driven by a sinusoidal source, it can be a sinusoidal current source or a sinusoidal voltage source. And if the linear circuit reaches steady state, then at steady state, every voltage and every current in that circuit is also going to be sinusoidal at the same frequency. This is the essence of a linear system. You understood? Every voltage and every current will also be sinusoidal at the same frequency. So what will get modified? It's only the amplitude and the phase angle that will get modified, but not the frequency. And this is true as long as the circuit is what? Linear. Okay. So because at steady state, which is also called as sinusoidal steady state, every voltage and every current is what? Sinusoidal. We have a new notation to represent these sinusoidal functions of time. And what is that new notation? It is called the phasor notation, wherein every sinusoidal voltage and every sinusoidal current will be represented as a complex number. Will be represented as what? A complex number. And okay, it is like this, right? So for example, we got two very important results. First is what? If you have a sinusoidal voltage V of t, which is some Vm cos omega t plus theta. We have a sinusoidal voltage which is some Vm cos omega t plus theta. Now this voltage right now, it is a function of time. It is represented in time domain. If you want to represent the same thing in phasor domain, how will you do it? First of all, in phasor domain, you know this small v, it becomes what? Capital V. And to express this sinusoidal quantity in the phasor domain, I told you what? First you simply write down the amplitude followed by the phase angle. What is the amplitude? It is Vm followed by the phase angle, that is what? Angle theta. And then look at whether the sinusoidal function is what? In terms of cosine function or sine function. If it is cosine, then you just leave it like that. But if it is expressed in terms of what is sine function, that is what? Sine omega t plus something and so on, then you should add an extra factor which is what? Minus j. Right now it is what? In terms of a cosine function. We just have to leave it like that. Okay. And similarly, let's say we have a current which is represented in terms of a sine function, and let it be something like Im sine omega t plus some phi. Now what is the same current in phasor domain? Again, small I in the phasor domain, it will become what? Capital I. Small I in the phasor domain, it becomes what? Capital I. Once again, first you directly write down the amplitude followed by the phase angle. Now also, first you write Im angle phi. Once you write this Im angle phi, because it is what? Sine something, you just add this factor which is what? Minus j. So this is how you can very easily convert any time domain sinusoidal quantity into its corresponding phasor representation. Okay. So what exactly is this phasor? Phasor, as you can see, it's a complex number. So it's Vm angle theta. It is what representation? It is the polar form representation of the phasor voltage. Now the same Vm angle theta can be written as what? Vm cos theta plus jVm sin theta, and that is what? Representation of the complex number. It is a rectangular form of representing the phasor. Okay, Vm cos theta plus jVm sin theta, that is what? The rectangular representation of the phasor voltage, that is capital V. So you can represent a phasor either in polar form like what Vm angle theta, or in its rectangular form, which is Vm cos theta plus jVm sin theta. Okay. Now how do you get back the original sinusoidal voltage or current from the phasor? If you recall from yesterday's discussion, V of t, it is actually equal to what? Real part of the phasor voltage multiplied with e power j omega t, yes or no? So the actual sinusoidal voltage as a function of time, it would be real part of the corresponding phasor voltage, which is a complex number. So for small v of t, the corresponding phasor is what? Denoted by capital V. Now you multiply this phasor voltage with e power j omega t. So phasor voltage multiplied with e power j omega t, then you take the real part of this product, you will get back the actual sinusoidal voltage. In this case, you would get back Vm cos omega t plus theta. You understood? Yes. So that's the summary of yesterday's discussion with regard to what? Converting any time domain quantity into its corresponding phasor representation. Okay. And every phasor, which is a complex number, can be represented or shown on the complex plane, and the resulting diagram is called as what? The phasor diagram. Okay. And I also told you that phasor, in many ways, it is like a vector. In many ways, the phasor is like a vector, and to some extent, phasors will obey the laws of vector addition. Okay, so we got these three results for the three special cases, and this is what the more general result. So if you are adding two phasors, then what is the magnitude of the resultant phasor in terms of the magnitudes of the individual phasors and also the angle between the two phasors? The same thing also applies to the case where you are subtracting one phasor from the other phasor, then also you can just like that find the magnitude and so on. Okay, so if the two phasors are perpendicular, then the magnitude of the resultant phasor when you add those two phasors which are perpendicular is same as what? Finding the hypotenuse of a right triangle. Okay. So what is the statement here? Express the following sinusoidal quantities in phasor domain. Okay. So the first one is what? Some V of t equal to 100 cos 400t minus 30 degrees volts. This is the first sinusoidal voltage. How do you express this voltage in phasor form? First of all, in phasor form, small v of t will become what? Capital V. What is this 100? It is the amplitude. 400 is what? The frequency, 400 radians per second. And minus 30 degrees is what? The phase angle. I told you what? First you write down amplitude followed by phase angle. In this case, it would be 100 followed by minus 30 degrees volts. Because this voltage is represented as a cosine function, we just have to leave it like this. If it is sine, you should add an extra factor, which is what? Minus j. Okay. And then let's look at one more sinusoidal voltage. Let it be this V of t is equal to what? Minus 5 sine 580t minus 110 degrees volts. Again, we have to express this sinusoidal voltage in the phasor domain. Okay. Again, in phasor domain, small v becomes what? Capital V. Now you can think of this, minus 5 as the amplitude, minus 110 degrees as the phase angle. I told you what? First you write down amplitude followed by phase angle, which is minus 5 at an angle minus 110 degrees. And then because it is represented as a sine function, I told you what? Always you should add minus j. So minus j times minus 5 times minus angle minus 110 degrees. Okay. You can simplify this a bit. Minus j, what is minus j? Is it not angle minus 90 degrees? Yes or no? Plus j is what? Angle 90 degrees. Angle 90 degrees, it means what? E power j 90 degrees, which is cos 90 plus j sin 90. Similarly, angle minus 90 degrees is what? Cos of minus 90 plus j sin minus 90, which would be equal to what? Minus j. So minus j is what? Angle minus 90 degrees. In fact, minus j, would it not be along the negative imaginary axis? Plus j will be what? Along the positive imaginary axis. Minus j would be along the negative imaginary axis. What is the angle of the negative imaginary axis with respect to positive real axis? It would be minus 90 degrees. Because from positive real axis, you should rotate by 90 degrees in the clockwise direction. Yes or no? So if this is what the positive real axis, this is what the positive imaginary axis. Now this is what the negative imaginary axis. Yes or no? So from the positive real axis, you should rotate by an angle of 90 degrees, but in what direction? Clockwise direction. Whenever you rotate by some angle in the clockwise direction, then the actual value of the angle would be negative. But if you rotate by the same amount of angle in the anti-clockwise direction, then the angle would be positive. Always angle by default is in the anti-clockwise direction. Okay. Anyway, the reason why we are going through this is what? Just to assert that minus j is what? Angle minus 90 degrees. Okay. So look at this. So in place of minus j, I can write angle minus 90 degrees, and then you see minus 1 can be written as angle 180 degrees. Minus 1. First of all, minus 1, would it not be along the negative real axis? How do you rotate from positive real axis towards the negative real axis? Should you not rotate by 180 degrees? Yes. So minus 1 is same as what? Angle 180 degrees. So in place of minus j, I have already written angle minus 90 degrees. In place of minus 1, you say minus 5 is what? Minus 1 times 5. In place of minus 1, I will write angle 180 degrees. Okay. Angle 180 degrees. So minus 1 into 5. So 5, I will write it as it is. And then we have what? Angle minus 110 degrees. Look at this. Angle minus 90 degrees into angle 180 degrees into angle minus 110 degrees. Just add up all the angles. Minus 90 plus 180 is what? Plus 90. 90 minus 110 is what? Minus 20. So ultimately this can be written as what? 5 at an angle minus 20 degrees volts. Is it clear how we get to the final phasor representation? So the original time domain sinusoidal voltage is what? Minus 5 sine 580t minus 110 degrees. The same thing in phasor form is equal to what? 5 at an angle minus 20 degrees volts. So 5 at an angle minus 20 degrees, it means what? The phasor will have a length of 5 units and it will be at an angle of minus 20 degrees with respect to positive real axis. Angle of minus, okay, someone is asking how that 180 degrees has come. 180 degrees has come from this minus thing. Is it 5 or minus 5? It is minus 5. Minus 5 can be written as what? Minus 1 into 5. Now that minus 1 is what? Angle 180 degrees. Yes or no? angle 180 degrees is what? Cos 180 degrees plus j sin 180 degrees. Cos 180 degrees, is it not minus 1? Sin 180 anyway is what? 0. So angle 180 degrees is what? Minus 1. That's how we get this angle 180 degrees, and that is what? In place of minus 1. And apart from minus 1, you also have 5, and 5 is what written as such. Okay, understood, no? Okay. So angle 180 degrees is what? Minus 1. Angle 90 degrees is what? J. Angle minus 90 degrees is what? Minus j. Okay. Of course, angle 0 degrees is what? Just 1. So angle 180 degrees is minus 1. Angle 90 degrees is what? J. Angle minus 90 degrees is what? Minus j. Angle 0 degrees is what? 1. Okay. So what is this? 5 at an angle minus 20 degrees. In which quadrant will the phasor lie in? Angle minus 20 degrees. Does it not lie in 4th quadrant? Angle minus 20 degrees. Because angle is what? Negative. From the positive real axis, you should rotate by an angle of 20 degrees in the clockwise direction. In the clockwise direction. So this is how your V is going to be. At an angle 20 degrees in the, with respect to positive real axis in the clockwise direction. Okay. Let's look at one more sinusoidal voltage. So this time it is what? V of t equal to 3 cos 600t minus 5 sin 600t plus 110 degrees volts. So we have to convert this sinusoidal voltage into its phasor representation. So it consists of what? 2 terms, this voltage. First is what? 3 cos 600t. Next we have 5 sin 600t plus 110 degrees volts. In between the 2 terms you have minus. Okay. What we can do is we can directly convert each individual term into its corresponding phasor. What is the first term? 3 cos 600t. First of all, this 3 cos 600t can be written as what? 3 cos 600t plus 0 degrees. Yes or no? 3 cos 600t can be written as 3 cos 600t plus 0 degrees. Look at this. 3 cos 600t is what? 3 cos 600t plus 0 degrees. For 3 cos 600t plus 0 degrees, what is the phasor representation? Is it not simply 3 at an angle 0 degrees? Yes. So for this, it is what? 3 angle 0 degrees. And then we have this. Okay. Okay, in between the 2 terms you have minus, you write down minus. And then 5 sin 600t plus 110 degrees. 5 sin 600t plus 110 degrees. I told you what? First you directly write amplitude followed by phase angle. So for this second term within the yellow color brackets, amplitude is what? 5. Angle is what? 110 degrees. Since it is what? Expressed as a sine function, you should add minus j. So will it not be minus j5 at an angle 110 degrees? That's all. Again, 3 angle 0 degrees is what? Just 3, because angle 0 degrees is what? 1. And then minus of minus, it becomes what? Plus. And j can be written as what? Angle 90 degrees. And then 5 at an angle 110 degrees. Angle 90 degrees into angle 110 degrees. You can simply add up the 2 angles. It becomes what? Angle 200 degrees. So is it not same as 3 plus 5 at an angle 200 degrees? Yes. 3 plus 5 at an angle 200 degrees. Right now, if you look at the phasor representation, it is not exactly in polar form. Always your phasor should be expressed in polar form. Polar form, it means what? Magnitude followed by the phase angle. But right now, it is a mix of rectangular and polar. We have to simplify this into a very compact polar form representation. Magnitude followed by the phase angle. How do you do that? First term is what? 3. 3, you leave it like that. The second term is what? 5 at an angle 200 degrees. You expand this 5 angle 200 degrees into its real part plus j times imaginary part. Then you add the real parts, you add the imaginary parts to get the final rectangular form. Again you convert that rectangular into what? Polar. Yes, I hope the method is clear. So what is 5 at an angle 200 degrees? First you have what? 3. So 3 plus 5 cos 200 degrees plus j times 5 sin 200 degrees. 3 plus 5 cos 200 degrees plus j times 5 sin 200 degrees. That's all. 3 and 5 cos 200 degrees both are what? Real. The only imaginary term is what? 5 sin 200 degrees. Add up the two real parts, then you will get the phasor in rectangular form. Convert that rectangular into what? Polar. You will get the final phasor representation. Can someone please tell me the answer? At least you tell me what is the value of 3 plus 5 cos 200 degrees. Please tell me what is the value of 3 plus 5 cos 200 degrees, and also you tell me what is the value of 5 sin 200 degrees. 3 plus 5 cos 200 degrees is going to be what? The real part. 5 sin 200 degrees will be what? The imaginary part. Please tell me. Minus 1.698. So I'll write minus 1.7. Okay. So I'm guessing 3 plus 5 cos 200 degrees is what? Minus 1.7. Also tell me what is the value of 5 sin 200 degrees. What is the value of 5 sin 200 degrees? How much? Minus 1.71. Again, minus 1.71 is approximately what? Minus 1.7. Okay. Plus j times minus 1.7. That's all. Now this is what form? This is rectangular form. Real part is what? Minus 1.7. Imaginary part is also what? Minus 1.7. So does it not mean real part is negative, imaginary part is also what? Negative. Real part negative, imaginary part negative. The phasor would lie in which quadrant? It would lie in third quadrant. Okay. So if this is what? The complex plane, the phasor, it would be like this. So what is this? The real part, which is minus 1.7. What is this? Imaginary part, which is also minus 1.7. Because real and imaginary parts are equal in magnitude, you would expect that this angle. What is this angle going to be? Will it not be 45 degrees? This angle anyway is what? 90 degrees. So what is the angle of this phasor with respect to a positive real axis? Angle with respect to a positive real axis is what? This angle. So what is this angle? 90 plus 45 degrees. But is this angle in the clockwise or in the anti-clockwise direction? It is in the clockwise direction. So this angle, it would be minus 135 degrees. And what about the magnitude or length of the phasor? Because real and imaginary parts are what? Equal. Will it not be 1.7 root 2? The length of the phasor, it is like the length of the hypotenuse. It will be what? 1.7 root 2. Okay. Someone please tell me what is 1.7 root 2? 1.7 root 2. I want the value of 1.7 root 2. How can it be less than 1.7? 1.7 times root 2, right? 2.4. 1.7 into root 2, It will definitely be more than 1.7. 2.4. Okay. So 2.4, what is the angle? What's the angle? 135 degrees or minus 135 degrees? Angle is what? Minus 135 degrees, because this angle, it is in the clockwise direction. Any angle in the clockwise direction would be negative. So 2.4 at an angle minus 135 degrees volts. So the original sinusoidal voltage, which is what? 3 cos 600t minus 5 sin 600t plus 110 degrees, can be represented as what? 2.4 at an angle minus 135 degrees volts. Okay, this is 2.4. Very good. So we have one more sinusoidal voltage which has to be converted into what? The phasor domain, and that is 8 cos 4t minus 30 degrees plus again 4 sin 4t minus 100 degrees. Of course, the units are volts. So again, the goal is what? To convert this sinusoidal voltage into its phasor representation. Once again, the sinusoidal voltage, does it not consist of two terms? What is the first term? 8 cos 4t minus 30 degrees. And what is the second term? 4 sin 4t minus 100 degrees. So once again, let us convert each individual term into its phasor representation. What is the first term? 8 cos 4t minus 30 degrees. Is it not simply 8 at an angle minus 30 degrees? What is the second term? 4 sin 4t minus 100 degrees. Again, 4 sin 4t minus 100 degrees. I told you what? First you write 4 at an angle minus 100 degrees. Since it is what? Expressed in terms of a sine function, you should add this minus j thing. You should add this minus j thing. That's all. This can be further written as what? 8 angle minus 30 degrees. Minus j is what? Angle minus 90 degrees. Angle minus 90 degrees into angle minus 100 degrees is what? Angle minus 190 degrees. Yes, or angle minus 90 into angle minus 100 degrees is what? Angle minus 190. And that will be 4 at an angle minus 190 degrees. That's all. So now we have sum of two complex numbers, and both the complex numbers are written in polar form. So how do you add the two complex numbers? First you convert each complex number in polar into what? Rectangular. You will get the real and imaginary parts. You add the two real parts, you also add the two imaginary parts. Then you will get the final single complex number in rectangular form. Again, convert that rectangular form into what? Polar form. Please do it and tell me what is the final polar form representation of this sum. Final polar form representation. 2.989 minus j 3.306. It must be correct. Are you sure? Yeah, that's correct. Dineshwaran, very good. So this thing in rectangular form, it would be 2.988 minus j 3.305. In which quadrant does this complex number lie in? Real part 2.988, is it not positive? Imaginary part minus 3.305, is it not negative? Real part positive, imaginary part negative. It lies in what? The fourth quadrant. Any phasor or any complex number that lies in fourth quadrant, the angle is going to be negative, and it lies between what? 0 degrees and minus 90 degrees. Yes, someone tell me this in polar form. Magnitude of this complex number followed by the angle, and the angle, it would be minus tan inverse 3.305 divided by 2.988. Yes or no? So angle of V, it would be minus tan inverse 3.305 divided by 2.988. What is the magnitude? Minus 47.88 degrees, that is the angle. Very good. Okay, so now we have the final thing. Magnitude, how do you find the magnitude? Square root of real square plus imaginary square. Yes or no? Square root of 2.988 square plus 3.305 squared will give you what? The magnitude. And that magnitude is how much? 4.45, followed by the phase angle, which is minus 47.87 degrees, units volts. Okay. So earlier what we have done, we are given the voltage in the time domain, sinusoidal voltage, it was given in the time domain, and we converted each and every sinusoidal voltage into its phasor representation. Now we will be given the phasors, we have to go from phasor domain to the time domain, back to the time domain. So what is the first, this thing, capital I. Capital I is what? Phasor current. Capital V is what? Phasor voltage. So capital I, it is some J10 amperes. You see, if you want to go from phasor domain to time domain, you should express the phasor in polar form. If you want to go from phasor domain to time domain, you should express the phasor in polar form, because polar form is what? Magnitude followed by phase angle. And the magnitude of the phasor is same as what? Amplitude of the actual sinusoidal current or voltage. Magnitude is same as what? Amplitude. Yes, it can also be equal to what? RMS in the case of what? Power systems or machines. But here magnitude of the phasor will directly be equal to what? The amplitude of the corresponding sinusoidal current or voltage. So what is this J10 representation? J10, is it not rectangular form? What is J10 in polar form? J10 in polar form, is it not 10 at an angle 90 degrees amperes? Yes or no? J10 is what? 10 at an angle 90 degrees amperes. Now look at the phasor current, is it not in the polar form? 10 is what? Magnitude, 90 degrees is what? The phase angle. Now you know, we can easily go back to time domain. So in the time domain, capital I will become what? Small I of t. I told you what? This 10 is what? Amplitude. Write down 10, then cos omega t plus the phase angle, which is 90 degrees. That's all. 10 cos omega t plus 90 degrees. Of course, units would be amperes. What is this cos omega t plus 90 degrees? Cos of 90 plus x is what? Minus sin x. Yes or no? Cos 90 plus theta is what? Minus sin theta. By the same token, this 10 cos omega t plus 90 degrees can be written as what? Minus 10 sin omega t. What is it? Minus 10 sin omega t. I hope it is clear. Okay. So in this way, you can convert any phasor back into its time domain sinusoidal representation. Okay. But before you convert any phasor into time domain, you should express the phasor in what? Polar. Directly you can write it in time domain. Express the phasor in which form? The polar form. Okay. Well, our second phasor current is what? This 20 plus J10 amperes. The second phasor is what? 20 plus J10 amperes. Express this phasor in time domain. That means what is I of t? What is the corresponding I of t, 20 plus J10 amps. First of all, the given phasor is in which form? It is in rectangular form. Real part plus j times imaginary part, 20 plus j10, that is what the rectangular form. So before you convert this phasor into a time domain, you should express the same phasor in polar form. Yes. $20 plus J10. Please note down this thing. 20 plus J10. Suyog, this is the previous slide. Okay, Dineshwaran is saying 22.36 at an angle 18.434 degrees. Okay, I'll go with that. So the same phasor which is given in rectangular form, in polar form it would be 22.36 at an angle 26.56 degrees. Again, units are what? Amperes. Now it is in polar form. You can easily go back to what time domain? 22.36, which is what? Magnitude of the phasor will be same as what? Amplitude of the corresponding sinusoidal current. Whereas this 26.56 degrees, which is the angle of the phasor, will be same as what? The phase angle of the corresponding sinusoidal current. You can easily go back to time domain from here. So I of t, it would be 22.36 times cos of omega t plus 26.56 degrees units amperes. That's all. This is how you go from phasor domain back to the time domain. I hope it is clear. Okay. There is one more phasor current. Capital I is equal to what? 20 plus j times 10 at an angle 20 degrees amperes. Again, the goal is what? To convert this into time domain. So from this capital I, you should get the expression for small I of t, the same current in time domain. Again, clearly the given phasor is not in polar form. You should simplify it into a compact polar form. Then you directly go from phasor domain to the time domain. 20 plus j10 angle 20 degrees. You can do it in multiple ways. Okay. 20 plus again j is what? Angle 90 degrees. J is what? Angle 90 degrees. If you want, you can write j as what? Angle 90 degrees. Angle 90 degrees into angle 20 degrees, it would be angle 110 degrees. So this can be written as what? 20 plus 10 at an angle 110 degrees, amperes. Again, expand this 10 angle 110 degrees into what? Real part plus j times imaginary part. Then to that real part, you add 20 to get the final real part. And also you will have the final imaginary part. Again, that rectangular form, you convert it into polar form. Someone please tell me the polar form representation of this. 20 plus 10 at an angle 110 degrees. At an angle 19 at an angle 29.54. Okay. Approximately this capital I is equal to what? 19 at an angle 29.54 degrees. Again, units are amperes. So now that we have the current in the polar form, or the phasor current in the polar form, you can now directly go to what? Time domain. So in the time domain, capital I becomes what? Small I. Capital I will become what? Small I. This 19, which is the magnitude, will be same as what? Amplitude. So 19 cos omega t plus 29.54 degrees amperes. 19 cos omega t plus 29.54 degrees amperes. So understood, right? So what have we done here? We have done two exercises. One exercise is what? To convert any time domain sinusoidal quantity into its phasor representation. The next exercise we undertook is what? Going from phasor domain back to time domain. You should be very comfortable going from time domain to phasor and back to time domain from phasor domain. Because remember, we will be doing all the analysis in the phasor domain. Yes, as we go along, you will understand that the entire analysis will be done in what? The phasor domain. But in the end, we want the final result in what? Time domain. So in the end, we should convert phasor back into the time domain. Okay. And you know, when it comes to sinusoidal quantities, be it sinusoidal voltage or sinusoidal currents, we have the notion of one quantity leading or lagging the other quantity. Okay. So let's look at that notion of leading and lagging a bit. Okay. So let's say we have a sinusoidal voltage which is 5 cos 3t plus 60 degrees volts, and we have a sinusoidal current which is some 10 cos 4t plus 20 degrees amperes. So these are the two sinusoidal quantities we have. One is what? A sinusoidal voltage. The other one is what? Sinusoidal current. Tell me which one is leading between the voltage and the current. Which one is leading? Please type in the chat box. Which one is leading? Voltage or current? What is the angle of the voltage? 60 degrees. What is the phase angle of the current? 20 degrees. Angle of voltage is what? 60 degrees. Angle of current is what? 20 degrees. Which one is leading? Which one is leading? Okay, everybody is saying voltage. First of all, you cannot compute the phase difference. You should not take the phase difference between the voltage and current, because both the voltage and current are not at same frequency. You can compare the phases of two sinusoidal quantities. Listen carefully. You can compare the phases of two sinusoidal quantities only when the two sinusoidal quantities are at same frequency. Are the voltage and current at same frequency? Voltage is at a frequency of 3 radians per second. Current is at a frequency of 4 radians per second. Do not ever compare the phases of these two quantities, because both are not at same frequency. Is this point clear? So you should not say that voltage is leading current or current is lagging voltage. You should not talk about the phase difference between these two, because both are not at same frequency. You understood? Yes. So here the bottom line is what? Do not take the phase difference, because both are not at same frequency. Is this point clear? It's a simple point, but you should know it, okay? Because both the current and voltage are not at same frequency. You should not say one is what leading, the other one is what lagging, and so on, okay? Let's take up one more example. So once again, let's say we have a voltage which is some 10 cos 40 plus 30 degrees volts, and we have a current which is some 5 sine 40 minus 20 degrees volts. So this time, can we take can we say, or can we find out which one is leading and which one is lagging? Just say yes or no. Yes, is it all right if we say one is leading and another is lagging? Say yes or no. Because both are at same frequency, yes. Because both, see, if you want to take the phase difference between two quantities, the only thing is what? Both should be at the same frequency, yes. This time, definitely you can say which one is leading and which one is what, lagging. So now the question is, which one is leading? What is the phase angle of the voltage? 30 degrees. What is the phase angle of the current? Minus 20 degrees. Phase angle of voltage is what? 30 degrees plus 30 degrees. Phase angle of the current is what? Minus 20 degrees. So tell me which one is leading? Which one is leading, voltage or current? Phase angle of voltage is what? 30 degrees. Phase angle of current is what? Minus 20 degrees. Which one is leading? Phase angle of voltage is what? Plus 30 degrees. Phase angle of current is what? Minus 20 degrees. Which one is leading? Which has a greater phase angle? Which has a greater phase angle? Well, it looks like the voltage has a greater phase angle of plus 30 degrees as compared to the current, which has a smaller value of phase angle and which is equal to what? Minus 20 degrees. So plus 30 degrees is what? More than minus 20 degrees. In fact, the difference between plus 30 and minus 20 is what? 50 degrees. So if you say that voltage leads current by 50 degrees, it is incorrect. So do not ever say that V leads I by 50 degrees. If you make the statement, this is what? Totally incorrect. This is totally incorrect. It looks like the phase angle of voltage is what? Plus 30 degrees, and the phase angle of current is what? Minus 20 degrees, and the phase difference is what? 30 minus 20, which is 50 degrees. So you might say, or if not you, somebody else might say, voltage leads current by 50 degrees. But this is incorrect. See, if you want to directly take the phase difference, in this case, 30 minus 20, which is what? 50, both should be expressed in terms of what? Sine or cosine. Both quantities should be expressed in terms of sine or cosine. Yes, voltage is expressed as what? A cosine function, whereas the current is expressed as a sine function. In that case, you cannot simply compute the phase difference. Yes, you can compare the phases, but that phase difference is not simply equal to what? Like in this case, 30 minus 20, which is what? 50. Both should be expressed in terms of what? Cosine, or both should be expressed in terms of what? Sine. So you have to do some modification. I hope the point is clear. Do not directly take the phase difference and say that V leads I by 50 degrees. You understood? Yes. So this statement, it is what? Incorrect. Okay, this time let's say we have a sinusoidal voltage V of t, which is some 5 cos 3t plus 30 degrees, and we also have a sinusoidal current which is minus 10 cos 3t minus 40 degrees. Okay, so V of t is what? Volts, I of t is what? Amperes. So this time, can we find the phase difference? Yes or no? To find the phase difference, both quantities must be at same frequency. That is enough. So V of t, the voltage, is at how much frequency? Any doubt? Someone raised hand. Okay, it might be accidental. So the point I am making is what? Both the voltage and current are at same frequency. Definitely you can say something like one will lead the other or the other one will lag the previous one. But here the question is, how much is the phase difference? So I told you what, both should be at same frequency. Yes, both are at same frequency. Both should be expressed in terms of cosine. Look at this, V of t is what? Cosine function. I of t is also what? Cosine function. Again, if you directly take the phase difference, what is the phase of the voltage, or what is the phase angle of the voltage? Plus 30 degrees. What is the phase angle of the current? It looks like minus 40 degrees. What is the phase difference? 30 degrees minus 40 degrees is what? Plus 70 degrees. So phase difference between voltage and current is what? 70 degrees. So it looks like V leads I by 70 degrees. So if you make a statement like V leads I by 70 degrees. Why is 70 degrees? Because 30 degrees minus 40 degrees is what? 70 degrees. So if you make a statement like V leads I by 70 degrees, then also this statement is going to be false or incorrect. You cannot simply say that voltage leads current by 70 degrees. Why? Because if you look at the amplitude of the voltage, it is what? Positive. But if you look at the amplitude of the current, it is what? Negative. So one is positive, the other one is what? Negative. In that case, you cannot simply compute or take the phase difference. Okay, this angle minus this angle, you cannot do it. You can directly take the phase difference only when both the quantities are expressed in terms of what? Sine, or both are expressed in terms of cosine. And that too, both should be expressed in terms of sine or cosine with a positive amplitude. If both amplitudes are negative, fine. If both amplitudes are positive, then also fine. But if one amplitude is what? Positive, the other amplitude is what? Negative, then you cannot directly take the phase difference. You have to do a bit of manipulation before you compute the phase difference. You understood? Yes. So what is the summary of this discussion? To directly take the phase difference. To directly take the phase difference. Number one, of course, the phase difference itself can be taken only when the two quantities are at same frequency. If they are not at same frequency, you should never compare the phases of both the quantities. You can compare the phases of two quantities and say one quantity will lead or the other quantity will what? Lag, and so on, only when both the quantities are at same frequency. So to directly take the phase difference, number one, both should be expressed in terms of sine or cosine. Number two, both should have a positive amplitude, or it is also alright if both have a negative amplitude. So both should have, both meaning what? Both the quantities for which you are comparing the phases or taking what? The phase difference, both the quantities should have a positive amplitude, or both should have what? A negative amplitude. But you know, this negative amplitude, it's kind of rare, because when we represent any sinusoidal quantity, we always represent it with a positive amplitude. Yes or no? 5 volt sine omega t. You will never say minus 5 volt sine omega t, even though both are technically same, but you will always say it has what, 5 volts sin omega t, which means amplitude will in general be positive. Okay. So is it clear? I mean, are the 2 points clear? First of all, to compare the phases, both quantities should be at same frequency, and then to be able to directly take the phase difference between the 2 quantities, both should be expressed in terms of what, cosine, or both should be expressed in terms of sine. Not only that, both quantities should have a positive amplitude, or both quantities should have what, a negative amplitude. In that case, you can directly take the phase difference. Okay. In fact, if you go back to our previous examples, so in the first case, because both are not at same frequency, it does not make any sense to compare the phases. Okay. Now, well, in the second case, both are at same frequency, you can definitely compare the 2 phases, but the thing is what, you cannot directly take the phase difference and say V leads I by 50 degrees. So in that case, which one is actually leading and which one is actually lagging, and also by how many degrees. Okay. And for that, what you can actually do is what, represent each of the quantities in the phasor form. Okay. So V of t is what, 10 cos 40 plus 90, 30 degrees. So is it not same as capital V is equal to 10 at an angle 30 degrees, yes or no? Similarly, the current, which is what, 5 sin 40 minus 20 degrees, can also be written as what, capital I 5 sin 40 minus 20 degrees. First of all, you write 5 at an angle minus 20 degrees, then you add minus j, since it is what, expressed in terms of a sine function. Okay. So will it not be minus j times 5 at an angle minus 20 degrees amperes? Minus j is what, angle minus 90 degrees. Angle minus 90 degrees into angle minus 20 degrees is what, angle minus 110 degrees. That's all. So 5 at an angle minus 110 degrees amperes. Now what is the angle or the phase of the voltage? Look at the 2 phasors and decide which one is leading and which one is what, lagging. It is very simple. What is the angle of voltage? Angle of voltage is what, 30 degrees. What is the angle of the current? It is minus 110 degrees. Clearly, angle of voltage, is it not greater than the angle of the current? Angle of voltage greater than angle of current. That means what, voltage leads current. Yes, voltage leads current. And also, what's the difference between the 2 angles? Angle of voltage minus angle of current. 30 minus 110, is it not 140 degrees? So first of all, angle of voltage greater than angle of current, that itself means what? Voltage leads current. And the angle of voltage minus angle of current, that is the phase difference between voltage and current, is what? 140 degrees. And this means what? In this particular case, V leads I by 140 degrees. Voltage leads current by 140 degrees. In fact, the angle between the voltage phasor and the current phasor, it would be 140 degrees. Angle between the voltage phasor and the current phasor, it would be 140 degrees. Voltage phasor angle is what? 30 degrees. So voltage phasor lies in what? First quadrant. Angle of the current is what? Current phasor is what? Minus 110 degrees. Minus 110 degrees, it lies in what? Third quadrant. So voltage lies in what? First quadrant. Current lies in what? Third quadrant. And the angle between those two is what? 140 degrees. So voltage leads current by 140 degrees. And then if you look at this case, again V of t is what? 5 cos 3t plus 30 degrees. And I of t is what? Minus 10 cos 3t minus 40 degrees. First of all, both the voltage and current are at same frequency. Because they are at same frequency, we can definitely compare the phases of the voltage and the current. But then, because both do not have the same sign for the amplitude, both do not have the same sign for the amplitude. One amplitude is what positive, the other amplitude is what negative. You cannot just directly take the phase difference and say V leads I by 70 degrees. The actual thing would be different. Now let's find out which one is actually leading and also by how much. Okay, and for that you simply have to convert each quantity into its phasor form. So small v of t in phasor form, it would become capital V. So what is this phasor voltage capital V? Would it not be 5 at an angle 30 degrees? Yes or no? 5 cos 3t plus 30 degrees. The phasor form, it would be 5 at an angle 30 degrees volts. In the same way, let us also convert the current into its phasor representation. Minus 10 cos 3t minus 40 degrees. Again, this minus 10 is like the amplitude, minus 40 degrees is like the phase angle. Cosine means what? Don't add that minus j factor. You simply write the phasor current directly as what? Minus 10 at an angle minus 40 degrees. Minus 10 at an angle, sorry. Minus 10 at an angle minus 40 degrees amperes. Well, if you represent the phasor in polar form, always the magnitude has got to be positive. But right now the magnitude is what? Like minus 10, which is not positive. First of all, that minus 10 is same as what? Minus 1 into 10. What is minus 1? Angle 180 degrees. So minus 10 is same as what? Minus 1 into 10, where that minus 1 is same as what? Angle 180 degrees. So angle 180 degrees times 10 times angle minus 40 degrees. Angle 180 degrees into angle minus 40 degrees is what? Angle 140 degrees. So 10 at an angle, 140 degrees amperes. That's all. That's all. So what is the angle of the voltage? It is 30 degrees. What is the angle of the current? It is 140 degrees. So from here, can't we see that the angle of current is more than the angle of the voltage? Yes. So angle of I, angle of I is greater than angle of V. And also angle of I minus angle of V. Phase difference between current and voltage is what? 140 minus 30, which is 110 degrees. That means what? Ultimately, we can say that current leads voltage by 110 degrees. Okay. So this means I leads V by 90, not 90, 110 degrees. Okay. I hope it is clear to all how to find out which quantity will lead and also by how many degrees. You should always be able to judge which one is leading and also by how much angle. Okay. Just try to answer this question. Please type your answer in the chat box. There are two quantities, I1 and V1. Both are at same frequency, 120 pi radians per second. Both are at 120 pi radians per second. Because both are at same frequency, we can definitely compare the two phase angles. Okay. And the question is what? To find the angle by which I1 lags V1. Find the angle by which I1 lags V1. Okay. Find the angle by which I1 lags V1. You see, the angle by which I1 lags V1, is it not same as angle by which V1 leads I1? Yes or no? Be clear about this. So I was saying what? Angle by which I1 lags V1. Listen carefully. Angle by which I1 lags V1 is same as what? Angle by which V1 leads I1. Do you all agree with that? Angle by which I1 lags V1 is same as what? Angle by which V1 leads I1. Okay, so here angle by which I1 lags V1, it is same as what? It is same as angle by which V1 leads I1. Angle by which I1 lags V1 is same as what? Angle by which V1 leads I1. And what is that angle by which V1 leads I1? Again, this is same as what? Phase difference between V1 and I1. Understood? Angle by which V1 leads I1 is same as what? Phase difference between V1 and I1. That's all. Now you can easily do it. So small v1 in the phasor form, small v1 in the phasor form. In fact here no need to convert to any phasor thing, because both the voltage and current are expressed as what? Cosine functions with positive amplitude. You can directly take the phase difference. Okay. So what is angle of V1 minus angle of I1? You can directly take the phase difference. Phase of voltage is what? Minus 40 degrees minus the phase of the current, which is 20 degrees. So minus 40 minus 20 is what? Minus 60 degrees. So angle of V1 minus angle of I1 is what? Minus 60 degrees. Okay. That means what? Angle by which I1 lags V1 is what? Minus 60 degrees. Because angle by which I1 lags V1 is same as what? Angle by which V1 leads I1, and V1 leads I1 by an angle of minus 60 degrees. So tell me, in this case, between the voltage and current V1 and I1, which is actually leading? Is it the voltage that is leading or the current that is leading? Voltage leads current by minus 60 degrees. Current, it's the current. Yes or no? Voltage leads current by minus 60 degrees. You see, voltage leads current by minus 60 degrees is same as what? Current leads voltage by plus 60 degrees. Yes or no? Angle of V1 minus angle of I1 is what? Minus 60 degrees. Is it not same as angle of I1 minus angle of V1 equal to what? Plus 60 degrees. Yes or no? Angle of I1 minus angle of V1 is what? Plus 60 degrees. So clearly I1 leads V1 by 60 degrees. But the question is what? To find the angle by which I1 lags V1, and that answer is what? Minus 60 degrees. So the answer to this question is what? Minus 60 degrees. But the final conclusion is what? That the current leads voltage by 60 degrees. Okay. So here the final conclusion is what? I1 leads V1 by 60 degrees. I1 leads V1 by 60 degrees. But the answer to this question is what? Minus 60 degrees. Okay. Please type your answer for this in the chat box. Find the angle by which I1 lags V1 if V1 is what? The same, 120 cos 120 pi t minus 40 degrees, but this time the current is what? 1.4 sin 120 pi t minus 70 degrees. First of all, both are at same frequency. You can definitely compare the two phases, okay? Once again, same angle by which I1 lags V1 is same as what? Angle by which V1 leads I1. Angle by which I1 lags V1 is same as what? Angle by which V1 leads I1. Angle by which V1 leads I1 is again same as what? Angle of V1 minus angle of I1. Now if you look at the given voltage and the current, both are not expressed in terms of the same function. Voltage expressed in terms of what? Cosine, whereas the current expressed in terms of what? A sine function. If both are what? Expressed in terms of cosine with a positive amplitude, then simply you can take the phase difference. No need to do any kind of manipulation. But here, since the voltage is what? Cosine and current is what? Sine, you should do some manipulation. And the best way is what? To just express both the quantities in phasor domain, okay? Look at this. So small v1 in phasor form, it becomes what? Capital V1. So what is capital V1? 120 at an angle minus 40 degrees volts. In the same way, small I1 in the phasor form will become what? Capital I1. Again, amplitude is what? 1.4. Angle is what? Minus 70 degrees. Since it is what? Sine, first you write minus j and then you write 1.4 at an angle, 1.4 at an angle minus 70 degrees. Again, minus j is what? Angle minus 90 degrees. Angle minus 90 degrees into angle minus 70 degrees is what? Angle minus 160 degrees. So this can be written as what? 1.4 at an angle minus 160 degrees, okay? Amperes, that's all. So what is the angle of the voltage? It is minus 40 degrees. What is the angle of the current? Minus 160 degrees. I'll just write it. So here, angle of V1 is what? Minus 40 degrees. Angle of I1 is what? Minus 160 degrees. So from this, can't we see that angle of V1 is greater than angle of I1? I mean, minus 40 degrees is what? Greater than minus 160 degrees. So angle of V1 is greater than angle of I1. Angle of V1 greater than angle of I1. That means what? In this case, V1 leads I1. V1 leads I1. In fact, our answer is what? Angle of V1 minus angle of I1. What is angle of V1 minus angle of I1? Minus 40 minus of minus 160. Is it not 120 degrees? Did you also get 120? Yes, good. So what is the final conclusion? Voltage leads current by 120 degrees. That is the final conclusion. V1 leads I1 by 120 degrees, okay? Let's look at one last example. Once again, same thing. V1 is what? Same as before, 120 cos 120 pi t minus 40 degrees. And this time I1 is what? Minus 0.8 cos 120 pi t minus 110 degrees. Again you should find what? Angle by which I1 lags V1. Angle by which I1 lags V1 is same as what? Angle by which V1 leads I1. Angle by which V1 leads I1. Angle by which V1 leads I1 is same as what? Phase difference between V1 and I1. Angle of V1 minus angle of I1. Once again, if you look at the voltage and the current, both are at same frequency, both are expressed in terms of cosine, but both do not have the same sign for the amplitude. One amplitude is what? 120, the other amplitude is what? Minus 0.8. One is positive, the other is what? Negative. I told you what? If you want to directly take the phase difference, both should be expressed in terms of cosine with a positive amplitude, or both should have what? Negative amplitude, but here that is not the case. You can easily convert each of the two quantities into its phasor representation. So small v1, it becomes what? Capital V1. So what is capital V1? 120 at an angle minus 40 degrees. What is capital I1? Minus 0.8 at an angle minus 110 degrees. Okay. Again, minus 1 is same as what? Angle 180 degrees. So there is what? Angle 180 degrees. In fact, directly I'll write it. Minus 1 is what? Angle 180 degrees. Angle 180 degrees into angle minus 110 degrees is what? 180 minus 110, which is 70. So this can be written as what? 0.8 at an angle 70 degrees. There is what? Volts. There is what? Amperes. Okay. That's all. So now what is the angle of the voltage? It is minus 40 degrees. What is the angle of the current? It is 70 degrees. Angle of voltage is what? Minus 40 degrees. Angle of current is what? 70 degrees. Now our point of interest is what? Phase difference between voltage and current. Is it not minus 110? I am getting minus 110. Very good. So phase difference between voltage and current is what? Minus 110 degrees. That's all. Angle by which I1 lags V1 is how much? Minus 110 degrees. But what is the final conclusion here? If you look at the two phase angles, one phase angle is what? Negative. The other phase angle is what? Positive. What is the phase difference? 70 minus, first of all, angle of I1 is greater than angle of V1, and that means I1 leads V1. That means what? I1 leads V1 by plus 110 degrees. I1 leads V1 by 110 degrees. You understood? Yes. So this is how you can compare the phases of any two sinusoidal quantities at same frequency and decide which one will lead and also by how much angle. I'll just make one last point. You see, the phase difference between any two sinusoidal quantities should always lie in the range minus 180 to plus 180. Yes. Phase difference will always lie in the range minus 180 degrees to what? Plus 180 degrees. Yes. Now let's say the phase difference between two quantities is what? 230 degrees. Let's say the phase difference is what? 230 degrees. Okay. Look at this. Phase difference is what? Some 230 degrees. But I told you what? The phase difference should lie in between minus 180 and plus 180. But looks like the phase difference is what? Outside this range and equal to some 230 degrees. Now how do you get this into our actual range between minus 180 and plus 180? You see, to the phase difference, you can always add or subtract any multiple of 360 degrees. Because 360 degrees is what? One full cycle. If the phasor rotates by 360 degrees, the phasor will stay at the same location. If you have a phasor and if it rotates by 360 degrees, will it not be at the same position? In fact, the phasor is continuously rotating at an angular frequency of what? Omega. Yes. But if you look at the phasor diagram, at every after every one time period, the phasor will be at the same position, because in one time period it will rotate by 360 degrees and come back to what same position. Again you look at t equal to what 2t, again it will rotate by 360 degrees and come back to what same position. So every time you look at the phasor at t equal to 0, t equal to capital T, t equal to 2t, t equal to 3t, t equal to 4t and so on, the phasor appears like it is fixed at that position, but the actual thing is what phasor is continuously rotating. In fact, all phasors are continuously rotating at the same frequency, because on a phasor diagram all phasors will be at same frequency. But you won't look at the instantaneous phasor diagram, you will only look at the phasor diagram at the intervals of one time period. You will look at it, you will look at the phasor diagram at capital T, at 2t, at 3t, 4t and so on, but every time all phasors will appear like they are constant at a fixed location. You understood? Yes. So right now the phase difference is what? 230 degrees. Now this 230 degree phase difference is same as what? 230 degrees. How do you get this 230 degrees into this range? By adding or subtracting any multiple of 360 degrees. If you add 360, it will further go out away from the range, but if you add minus 360 degrees, okay? So this is same as what? 230 degrees minus 360 degrees. Now 230 minus 360 is what? Minus 130. You understood? So phase difference of 230 degrees is same as what? A phase difference of minus 130 degrees. I'm sorry. Phase difference of 230 degrees is same as what? A phase difference of minus 130 degrees. Understood? So always, if you are, talking about phase difference, that value of phase difference that you specify should always lie in the range minus 180 to plus 180, and if at all during analysis the phase difference turns out to be a value which is outside this range, then you can always add or subtract any multiple of 360 degrees, either plus 360 degrees or minus 360 degrees, to get the phase difference within our range between minus 180 and plus 180. I hope this discussion is clear. Okay. So from the next session onwards, we'll get started with circuit analysis. Okay, analysis of circuits driven by AC sources, and the circuit reaches what? Steady state, and at steady state all currents and voltages are going to be sinusoidal, and you know how to represent those sinusoidal currents and voltages at steady state in the phasor domain as what? Simple complex numbers. Okay, I'll see you in the next session.